Hello everyone, this is Nirmit. Welcome back to another video. Today we are doing this hard lead code question 41. But trust me, if you know how to do this question, you can do it in just 2 minutes. Like in fact, less than 2 minutes even. It's just a 6 line code of this question. You just need to know the exact algorithm for this question, the exact pattern, which many people don't know. So before jumping into this question, I want to tell you about a very famous concept that somehow very less people know. So the concept is called cycling sort. I will first quickly write the code of this and then tell you what it exactly is. So this is the code, and this short 3 lines of code is called cycling sort. What it basically does is if you have an array like 2, 3, 5, 4, 1. So it just sorts like swaps all the elements of the array such that every element is at their place. That's everything this algorithm does, and it does in big of n time. You are seeing here two loops like for loop and then a while loop. So you might think that this is happening in big of n square, but that's not the case. Since every swap is happening one time and keeping the element at its place. So there are essentially happening n swaps only. So the time complexity of this algorithm is effectively big of n only. If I show you a dry run of this, I'm taking a bit more time on this algorithm because you need to know this cycling sort well, and if you know, it helps you very much in many questions. So yeah, suppose this is our array, and we go to the first element int I is equal to 0, I less than n. For the first element, we see this 2. It is greater than 0. It is less than equal to n, that is 5. Our n is 5. Just let me quickly enter it. N is equal to 5. So for I is equal to 0, we have that nums I is equal to 2, and it is not equal to nums of nums I, that is 0 is equal to 2, and it is not equal to nums of nums I, that is 2 minus 1, that is effectively nums of 1, that is 3. So we'll just swap these two numbers, and then it will become 3 2 5 4 1. Now we are still at I is equal to 0 because nums I, that is 0, nums 0. Now nums 0 is, we are still inside the while loop. Now num 0 is equal to 3, which is still not equal to nums of nums I, that is nums of nums I is 3, which is not equal to 3 minus 1, that is 2. That is equal to 5. So we just again swap it, and it will become 5 2 3 4 1. Similarly, now again it will not be equal to the position where it should be because nums 0 is equal to 5, and nums of nums I minus 1, that is nums 4, is equal to 1. So we'll just swap them again, and it will become 1 4. Sorry, here's a typo. It should be 2. Yeah. It will become 1 1 2 3. Sorry, just a second. Yeah. 1 2 3 4 5. And now we exit the while loop because nums I, that is nums of 0 is equal to 1, is equal to nums of nums I minus 1, that is 1 minus 1 nums 0. So we get out of the while loop. Now I is equal to 1. Here also the condition is satisfied. Then I is equal to 2, I is equal to 3, and then till 4 we move our loop goes on. And as you see, it is effectively big of n only because n swaps are happening and all the elements are at their place. So now that we have understood this question and completed with the dry run also, let's move on to the question. Believe me, this algorithm, guys, helps you in many questions, in many lead code questions like this one too. And this hard question becomes so easy with this algorithm, if you know. So this is a very famous question, first missing positive, and it asks that you are given an unsorted array. We have to return the smallest positive integer that is not present in the array. For example, when here we have 1, 2, 0, so we have 0 present, 1 present, 2 present, 3 is not present. So 3 should be the answer. In this case, 3, 4, minus 1, 1, we have 1 present, we don't have 2 present in the array. So our answer quickly becomes 2. Similarly, here we don't have 1 present itself, so our answer becomes 1. So, and the question clearly asks us in the optimal way to solve it in linear time in big O of n. Because yeah, so we will be solving the most optimal solution There are obviously other solutions also where you can draw a hash map, count the occurrence of each element, and then map it to its map to its number of occurrences and find the first element which is not occurring. But we'll be doing the most optimal solution here. First, you need to realize one trick. If you are given an array, and in the array, if uh, if any duplicate is present or any negative element is present, for example, if I have a -1 or 0 or any duplicate present in that array, then my answer will sure shot lie between 1 to n. Why? Because I need first non-negative, like I need first non-negative element, first positive element, which is not occurring in the array. So suppose I'm having an array of size n is equal to 4, and I have all the elements present here. So in that case, my array will look like 4, 2, 3, 1, or like suppose anything 4, 3, 1, 2, and the first non-negative element which is not happening in the array is n plus 1, that is equal to 5, and that is our answer. So but if any one duplicate, even a single duplicate exists, that is something like 4, 4, 1, 2, or a non-negative element, a negative element exists like -1, 3, 4, 2, so the answer has to exist between 1 to n. That would be the range of answer. So here the answer will then become one. Answer will be 1 is present, 2 is present, 3 is not present, so 3 will be the answer. Here 1 is not present itself, so 1 is the answer. So how will I do this? My approach will be, I will first send all the elements at their place, and then I will find the first place where a element is not occurring. For example, here, like let's take this example, -1, 3, 4, 2. I send all the elements in their place, so it becomes something like -1, 2, 3, 4. Then I iterate through the array, and I say that I see that -1, we don't have one at -1 we don't have one at 1th position, we have -1 there, so 1 will be answer. Similarly, we will send all the elements at their place, 1, 2, 3, 4. We begin iterating, we see 1 is at its place, 2 is at its place, 3 is at its place, 4 is at its place, and we have reached the end of the array. So our answer will become n plus 1, 5. Now let's move to coding. This is exactly a 6 to 7 lines code, very short code, just in 2 minutes. Let me show you the code. So first I take in n is equal to nums dot size, that is the size of our array. Then we quickly apply our cycling sort algorithm for int I is equal to 0, I less than n, I plus plus. While nums I is greater than 0 and nums I is less than equal to n, and nums I is not equal to nums of nums I minus 1. Mind you, here we are doing here we are using less than equal to, because if we don't use less than equal to, then it might cause us issues. We will never be reaching the n minus 1 element. And similarly, here we are doing greater than 0, because if an element is 0, then n nums I minus 1 will become -1, which will give us out of bounds. So yeah, in this case, we will just swap it. Swap nums I with nums of nums I minus 1. Cool, this much clear. Now we just begin iterating through our array once again. For int I is equal to 0, I less than n, I plus plus. If at any place nums I is not equal to I plus 1, then that is our answer. Return I plus 1. Otherwise, if we get out of this array and we haven't found the answer, then our answer will be n plus 1. And then just simple, I run it. Let's see, our code is running. I will submit it. Tada, it's the most optimal solution, beating everything. 100% test cases passed. Sorry, 100% runtime beaten. So yeah, this is the big O solution of this code, of this problem, this hard problem. And this concept, cycling sort, can be used at many questions. Like in this question also, cycling sort is used. There are many other questions on LeetCode which uses this concept. So yeah, I hope you got to learn something new from this video, and do drop a like, do comment whatever you need in future, and make sure to subscribe. Thank you so much for watching this video completely. Signing off. Bye bye.